Hello friends, today we will discuss a problem from exercise number A1.2 and we'll see how we can use some of our previously learned concepts in solving this problem. So let's take a look at the problem. Question number 6. Given that PQRS is a cyclic quadrilateral and also its diagonals bisect each other, what can you conclude about the quadrilateral? So we have been given that PQRS is a cyclic quadrilateral. Now what that means is that all the 4 points of the quadrilateral PQRS lie on the same circle and its diagonals also bisect each other. So we have to find that if this quadrilateral has any special properties or it is a particular quadrilateral or what. And we'll take a look at the solution for this. Here we have two premises. So first of all, let's list down what's given to us. First of all, PQRS is a cyclic quadrilateral, and secondly, its diagonals bisect each other. So these are the two important things that have been given to us, and we will try to find a conclusion based on these two premises. And moving on, here we have a circle and here is our cyclic quadrilateral. So this is PQRS, and right now it looks like a square, but it is not supposed to be any particular shape or any particular quadrilateral. It's just a description, so don't worry about that. And here are the diagonals, and these diagonals bisect each other, which means that this part is equal to this part and this part is equal to this part. We'll see that in more detail very shortly. So now let's try to see if this quadrilateral has some special properties or not. In triangle POS and triangle ROQ, so we are looking in this triangle POS, which is this one, and ROQ, which is this one. So let's see what we have. PO is equal to RO, which is given to us. So PO is equal to RO because the diagonals bisect each other. And again, we have been given that QO is equal to SO, which is QO and SO, and the diagonals bisect each other again. Next, we have angle POS is equal to angle ROQ, which are vertically opposite angles. So we know that vertically opposite angles are always equal to each other, and we have here angle POS, you can see this one, and angle ROQ, which is this one, and these are equal. So what we can derive from here is that thus triangle POS and triangle ROQ are congruent by side angle side. So these two are congruent as we have proved here using the side angle side rule. So these two triangles are congruent and we have proved it using the given premises. And let's move on and try to see if we can get anything more. So moving on. So again we have PQRS with us because it is very important that you mention the figure and you refer to it, because you refer to it again and again, you have to see it for better understanding, hence it is here. So again we'll take a look in triangle POS and ROQ, the same triangles ROQ POS. So here we have angle SPO is equal to angle QRO, congruent triangles. Now what this means is that SPO, let me highlight this angle right here, and QRO, this angle, are equal. Why? Because these are congruent triangles and we know that corresponding parts of congruent triangles are equal. Hence these angles will also be equal. And next we have that PS is equal to RQ. Why they are equal? Again, corresponding parts of a congruent triangles are equal, so we can say that these two sides are equal. And similarly, also angle OPS and angle ORQ are alternate interior angles, and this implies that PS and QR are parallel. So angle OPS is actually the same as angle XPO, a different way to write it, and angle ORQ is the same as QRO. So these two can also be taken a look at as alternate interior angles, And if they are equal, that it means that PS and QR should be parallel. If you are able to see this figure right here, PS and PQR, they can be considered parallel because the alternate interior angles, when you see this particular Z right here, are equal. So now what we have here, thus PQRS has a pair of opposite, equal and parallel sides, hence it is a parallelogram. So whenever a quadrilateral has opposite, equal sides and parallel also, then it is supposed to be a parallelogram, and we have learned about this earlier as well. So now we have proved that PQRS is a parallelogram. So this is the thing that we have got now, and let's move on and try to find if PQRS can be more than a parallelogram. So moving on, here again we have P, Q, R, S with us. It is very important that you take a look at the figure again and again. So now we're in the cyclic quadrilateral P, Q, R, S, and we can write that angle SPQ plus angle QRS is 180 degree. Now how can we write that? So we know this property that the sum of the opposite angles of a cyclic quadrilateral is 180 degree, and this is the property that we're using for this particular quadrilateral we have with us. And the next step which we have is, we have divided angle SPQ as a sum of angle SPO and QPO. Let me mark these angles right here for you. So this is angle QPO and angle SPO, and this angle SPQ is a sum of these two. And similarly, angle QRS is a sum of angle QRO, which is right here, and angle SRO, which is marked right here. So this is also equal to 180 degree. And what we have now, so we have proved this already, that for congruent triangles we have SPO is equal to QRO, and when you take a look in triangles QOP and SOR, you'll also get that angle QPO and angle SRO are equal. And you can also prove it because PQ will be parallel to SR, because we have already proved this quadrilateral to be a parallelogram. So you do not need to go for the congruent triangles bit again, because that is going to make your question only lengthier. So you can just see that since it is a parallelogram, these two angles are also going to be equal, and these we already had proved equal and parallelogram, so then also. So now what we will get finally, we will what we will do is that we will replace the equal angles. Like what we will do is that we'll get 2 times of QPO plus 2 times of QRO is equal to 180 degree. Now what we did is that we replaced angle SPO with QRO, and we replaced angle SRO with angle QPO. So here we get 2 times of these two, this we get the whole equation, 2 times of angle QPO plus 2 times of angle QRO is equal to 180 degree. And when we simplify it, we get angle QPO plus angle QRO is equal to 90 degree. So the sum of QRO and QPO is 90 degree. Now what this means, we have got this here, and what I would suggest to you at this point is that if you were not able to understand anything right here, it would be better if you would just pause this video and try to write this particular solution yourself and then understand, because this is very important. And if you were able to understand, let's move on and see the next part of this problem. So again, we have the quadrilateral PQRS with us. It is very important that you see this quadrilateral very nicely and you understand how we have drawn it also. So Earlier we discussed that how we got angle QPO plus angle QRO is equal to 90 degree, and what we are doing now is that in triangle PQR, in this particular triangle we are taking a look, and we can say that angle QPO plus angle QRO plus angle PQR is equal to 180 degree. So the sum of three angles of a triangle is 180 degree, and QPO, QRO and PQR are the angles of this particular triangle. So their sum would be 180. And when we replace the value of QPO plus QRO, we get this equation. And finally, we get that angle PQR is 90 degrees. So here you can see that this marks this angle to be 90 degree. And now what we get from here is that since this is already a parallelogram, PSR is also going to be 90 degree. And when you consider the property of a parallelogram and you try to solve for the two missing angles, they will also come out to be 90 degrees. Since PQRS is a parallelogram and opposite angles are equal, angle PSR is 90 degree and thus PQRS would be a rectangle. So PSR is also 90, and we can just, based on the property that if even one angle of a parallelogram is 90 degrees, it's going to be a rectangle, and hence we have got a rectangle with us. We have got that PQRS is a rectangle, and this is the solution of this particular question. So I hope that you were able to understand it and that this video was fun for you to watch. So now let's move on to some tips which will be beneficial for you. And yeah, so first of all, always read the question properly. It is very important to understand what the question is asking you. So read the question carefully and clarify everything, every doubt you have. And secondly, use the premises given to arrive at the final conclusion. So we were given some premises and we used them to arrive at a particular conclusion, and you should do the same. So this was it for today's video, and I hope you were able to understand the various concepts that were involved in solving this question. And thank you so much for watching.